All right, we are now ready for lesson 1-6, and you can see the title there, Two-Dimensional Figures. And our takeaway from today's lesson, there's two main takeaways. These are called objectives. We want you to be able to identify and name polygons, so we will cover that in this lesson. And then we will finish up, the second half of our lesson is using formulas to find perimeter, circumference, which of course is dealing with circles, and the area of two-dimensional figures. So that's our goal today, and so let's get started with identifying, defining some important terms that will show up in this lesson. So the first term we will identify is a polygon. So a polygon is a closed figure formed by a finite number of coplanar, right, on the same plane, segments called sides, such that, and then we have two follow-up statements to complete this definition, the sides that have a common endpoint are non-collinear. So before I go any further, let me just point out, what is that saying? So here's an example of a polygon. All right, so these segments are on the same plane, and the sides have a common endpoint. Okay, so there's a common endpoint that it's talking about, and that endpoint isn't on the same line as these two sides. That's really all that it's saying, just in case you weren't following. And then finally, finishing up our definition, each side intersects exactly two other sides, but only at their end points. So going back to that same example, these two sides intersect, but only at their end points. So in other words, I would not have one segment here and another segment just coming in and intersecting there at a midpoint, for example. All right, and those are probably commonsensical statements, but I think we need it to establish a complete definition of this term. So what I've done here is I've given you some examples of polygons. You can see that these fit our definition. And then over here we have some counterexamples. These are not polygons, and for various reasons. We could say here that these two lines do not just intersect at their end points, line segments actually. These line segments don't intersect at their end points, they intersect at a midpoint. So that violates this second statement that we made. This green shape is not a polygon because these are not straight line segments. This is a curve, has to be line segments. This oval shape, it's actually called an ellipse, obviously doesn't fit because we don't have line segments at all. This is not a closed figure like we said in our first statement. This is still left open. And then again, we have the intersection of a line segment with another line segment, but it's not at the end point of each. So that violates this second statement that we made. All right, so just wanted you to get a picture of what a polygon is, and then a picture of several examples of what it is not. Okay, some other terms that will come up not only in this course, but possibly throughout, or not only in this lesson, but possibly throughout the course. What a vertex is, we've touched on this before, so where these two segments intersect at their end points, that's called a vertex. That's the singular form, so I've highlighted here vertex M, vertex R is here. So vertex is singular, and if you talk about this as a group, these are called vertices, that's the plural. And then I've highlighted here that this is side PQ. It's just a line segment, which we talked about in our definition. When we name a polygon like this, we just name it by its vertices and just think about those being listed in consecutive order as they're given. And so I started here with M and then just went around in order. So you don't just randomly skip around. Just start with a vertex and then go in order from there. Probably most of the time you're going to see these appear in alphabetical order, but I would say that as long as they're in consecutive order going around the outside, that would be okay. All right, now let's talk about whether a polygon is concave or convex. So, brief definition here. To be convex, you should not have any points or lines on the interior. Okay, so this is a triangle and it is considered convex. So maybe it might help us understand convex by looking at the counterexample. So this is another, maybe you can think of it as it used to, maybe at one point was a triangle. But you can see how this bottom leg has moved so that we have two different lines that intersect at a point on the interior of this original triangle. I kind of like to think of something has been caved in. We use that phrase sometimes. Maybe a wall has been caved in by pressure or somebody kicked it or punched it, and you've basically taken a flat wall and you've made it protrude inward. And that's kind of the same thing here. We have basically taken an original triangle and we've caved it in, at least in this case it would have been that bottom leg. Versus here, all of our lines intersect on the exterior. No points or lines are found on the interior of the shape. So we're going to be classifying in just a minute polygons that are either convex or concave. All right, when we classify a polygon, we do it by the number of sides. Well, this is one way we give a polygon a name. We just count the number of sides. So I want you to be prepared for whatever given number of sides a polygon has. I want you to give it its proper classification accordingly. So we're familiar with a three-sided polygon, of course, is a triangle. When it's got four sides, it's a quadrilateral. 5 sides, we're probably familiar with a pentagon, just like our Pentagon building up in Washington. A 6-sided figure is a hexagon. 7-sided is a hep, H-E-P-T, agon. 8 is octagon. 9 is a nonagon. 10 is a decagon. 11 is a hendecagon. If you're interested, maybe you're kind of like me and you like the etymology of words. How did we get these names? They came from original Greek. And so, for example, hex in Greek is 6, hept is 7, oct is 8, nona is 9, deca is 10. And then when you get to 11, the Greeks did 11, 12, and so forth like this. You can see decagon in this root, and then when you add hen to it, hen is like saying one more than 10. So they did it like this. They started at 10, and then they just said one more than 10 would make 11. And then for 12, they used do, which is 2, decagon. So it's like 2 more than 10 is 12, and that's a dodecagon. And then after that, anything above 12, we just use whatever the number is, and we call it an n-gon. So a polygon with 15 sides, we would just call it a 15-gon. Okay, so you're just going to be responsible for actual names like this from 3 to 12. You should be able to classify by a particular name. But over that, 13, 14, 15, above that, you just put the number in, whatever that number is, the number of sides in place of gone. And that's the way you name it. Okay, almost done with terminology, and then we'll get to some actual assignment examples. So we have certain polygons in which we call these equilateral. Equilateral. An equilateral polygon is a polygon in which all the sides are congruent, same measure. Every side measures the same. And then we also have others that are equiangular. And you can probably figure out equa means equal, that little prefix, same sides in measure, and this is same angle measurements. So the angles are congruent for equiangular polygons. So we have one more classification. If a polygon is convex, okay, so just to kind of give you an example, this shape, letter A, is not convex. This is called concave because we have two lines that intersect on the interior. All right, so letter C would be convex. All right, just so you can, again, remember that term that we touched on a few minutes ago. So we could have a convex polygon that is both of these. All the sides are congruent and, notice, got to be both, and all the angles are congruent. This is called a regular polygon. Okay, but to be regular, both of these have to be true. If it's equilateral but not equiangular, then we would call it irregular. Okay, so let's just run through some examples. Letter A would be irregular because to be regular, it's got to be convex, and this is not convex. Letter B, it is convex. This mark means that the sides are congruent, and this little curve mark means the angles are congruent, and so this would be regular. It meets all the characteristics, qualifications for a regular polygon. Letter C is convex. We touched on that a minute ago. Two of the sides are congruent, but not all of them are, so this would be irregular. All right, so now let's get to perimeter, circumference, and area. And you've probably seen these terms before, but maybe a good refresher. Perimeter, we're talking about adding up all the side lengths of the polygon, coming up with the sum of the lengths of all the sides. Circumference is talking about the distance around a circle. And then area, we'll go ahead and fill this in, the number of square units needed to cover a surface. I did a lot of flooring in my house this summer, and so before I could lay the flooring, I had to figure out how much flooring I needed. So if this was kind of the shape of one of the rooms in my house, to know how much flooring to purchase, I had to find out how long a room is, how wide a room is, and then I took those two numbers and multiplied them together, and that told me how much flooring I need to cover that particular room in my house. So that's called area. And I went ahead and provided for you formulas. Now, obviously, you can look at your notes as you're doing the homework if you need it. But when it comes to quizzes and tests, these are formulas that I'm going to expect you to know without being given them. So make sure you practice these with purpose with a good understanding. I'm sure most of these, maybe all of these, you're already familiar with. Just make sure that you've refreshed your memory adequately and you're ready to use these when it comes quiz time or test time. All right, so we've touched on formulas for perimeter. Circumference obviously just deals with a circle. Area deals with all. And these are the shapes that you need to know the formulas for. Triangle, square, rectangle, and of course circle. And so now let's get into some exact homework examples. And so first of all, you'll be doing this kind of activity. Name each polygon by its number of sides. Okay, so let's do that first. So a polygon, this has 1, 2, 3, 4, 5. So a polygon with 5 sides is called a pentagon. So that'll be answer number 1. Then classify it as convex or concave. Well, we notice that 2 lines intersect on the interior, and so this is called concave. All right, that's answer part 2. And then we're supposed to do a classification based on if it's regular or irregular. Well, a concave polygon cannot be regular. Part of being regular is that it's convex. So we're going to say that this is irregular. All right, that's our answer for letter A, Roman numeral 1A. Letter B, let's see how many sides are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9 sides. So this is a nonagon. It is concave, it is convex. All right. We don't have any intersecting lines on the interior. And it's also regular because every side is congruent. You know that because every side has that little mark, means that they're the same in length. And the angles have this curve indicating that they're all the same measurement. So when that's true, sides are the same, angles are the same. This is regular. All right, and then letter C, it's got 4 sides, so this is a quadrilateral. It is convex because we don't have any lines or points on the interior. And we touched on this earlier. This was one of our previous examples. It is irregular because not all sides and angles are the same. Okay, so that's one type of exercise you will do. You'll have a block of problems that will involve that objective. And then the rest of your problems basically will be practicing the formulas that we use to find perimeter or circumference, if it's a circle. And then you're going to find the area. And these are going to be decimals, so any decimal you're just going to round to the 10th place. All right, so Roman numeral 2A is a square. All right, we know that it's a square because all of the angles are congruent, and these 2 sides, of course, were given as congruent. So that means all the sides are 11. So to find perimeter, you just add those up. So it's just like 4 times the side length, 4s. And that's going to be 4 times 11, of course, which is 44. So we'll say this is perimeter. You can just abbreviate. Oh, and I want you to include the unit of measurement. So this would be 44 feet. All right. To find the area of a square, it's just the side length squared. And so, of course, that's going to be 11 squared. So that's 121 feet squared. Remember that area, please try to remember this when you're doing your units. Area is always in a unit of measurement squared. So please tell me when you state your dimensions, do it in whatever it is, miles, squared, square miles, square feet, square inches. Please don't forget that when it comes to area. And then finally, let's see, that's it, because circumference, of course, we'll deal with letter B. So that's my final answer for letter A. For letter B, we're supposed to find the circumference of this circle. So for a circle, you really could do it two ways. If you're given the diameter, like we are, then the circumference is pi times the diameter. If you're given the radius, of course, it would be 2 times pi times r. So remember, diameter is really 2 radii. But since we're given the diameter, we might as well just use this form of the circumference of a circle. So when you're using your calculator here, please don't think of pi. Don't plug 3.14 in for pi. You probably already know that, but sometimes I'll run across people that actually type in 3.14. You want to use the actual button on your calculator that has pi on it. So pi times 12.8. And we're going to round to the nearest tenth, and so that's 40.2, and it's centimeters. So that's our circumference answer. And now let's find the area. So we looked at the previous slide that the area of a circle is found by doing pi r squared. All right, so the radius of this circle will be the diameter divided by 2. So the radius is 6.4. So to find the area, I'm going to do pi times 6.4 squared. All right, so let's go to our calculator. And once again, use the pi button. And then we're going to multiply that times 6.4 raised to the second power. And looks like to the nearest tenth, it's going to be 128.7 square centimeters. So again, just a reminder, when it comes to area, make sure you do it in units squared. All right, and then we'll do letter C. Didn't leave myself a lot of room. We'll try to squeeze this in over here. So the perimeter is just going to be these 3 sides added together. Pretty easy. 15 plus 17 plus 8. And that's 40 meters. And then for triangles, remember the formula to find the area. You have that on the previous slide. It's 1/2 times the base times the height. I'll just go ahead and write that here so you can see it again. I'm sure you've been exposed to this in your past. All right, so applying this formula, 1/2, the base of this triangle is 15 meters. And then the height is this vertical side, this vertical leg here, measured at 8 meters. And when we do this in our calculator, try to squeeze in our answer here, we get 60. 1/2 15 times 8 is 60 and it's going to be meters squared. So those are our two answers. Perimeter was 40 meters. Area is 60 square meters. Okay, so let's do one more example, and this will be my last one. So here we're told to graph this figure, plot these points, and then identify the figure, and then we're going to find perimeter and area. So let's plot point E, -1, -1. All right, label that. 2, 2 is point F. 5, -1 is point G. And 2, -4 is point H. All right, I'm going to do my best to draw straight line segments. Okay, so we have a four-sided figure. We know that it's a quadrilateral. It's possible that we could go even further and call this a square. So we're supposed to identify the figure, so quadrilateral. And then let's go ahead. We're supposed to find the perimeter. So to find the perimeter, we need to know the length of these sides. So fortunately, we have a formula that helps us find the lengths of these segments, the distance, in other words, between these 2 points. So it really doesn't matter. We can start with the distance between E and F. So let's just do this EF distance. Our distance formula is the difference between the x's squared. So -1 minus 2 added to the difference between the y's squared, same thing. So this is going to be -3 squared, which is 9. Same thing here. So this is going to be the square root of 18. And you're going to have your answers. It's not in the instructions, but you can put your answers here again in rounded decimal. So the square root of 18 in decimal form is 4.2. All right, so EF we know is 4.2. What about FG? It looks like a square, but we just don't know for sure. So let's find this segment FG using, again, distance formula. So the difference between the x's squared, +2, and the difference between the y's squared. Simplify this, so this is going to be -3 squared, which is 9, and this is going to be 3 squared, which is also 9. Looks like we got the same thing, the square root of 18, which is about 4.2. All right. So I know those two sides are the same, and I won't take the time, but if you kept on going, you would discover that all of these are actually the same length. So we're talking about a square to get specific. And so we've identified the figure, and then we're supposed to find the perimeter. So the perimeter is 4 times whatever the side length is. So that's 4 times 4.2. Four times 4.2 is 16.8. And then the area, of course, is side squared. 4.2 squared. Is 17.64 using our decimal equivalent 17.6. I'll put approximately since we rounded these. So there's our perimeter answer, and there's our area answer. There's our classify, identify answer, and that's it. So that's the kind of thing that you'll be doing on the last block of problems in your assignment. All right, so I think that takes care of our class notes, and I hope this helps you with your assignment, but if you still have questions, feel free to reach out to me, and I will see you next time.